The broadcast is now starting. All attendees are in listen-only mode.
Well, hi there, and welcome from Ventura, California, and from our other panelists across the U.S. to today's webinar, a case study on competitive advantage through on-premise rapid prototyping, which is sponsored by Objet Geometries and hosted by Desktop Engineering Magazine, the knowledge leader that design engineers rely upon to succeed in a global manufacturing market, and WebAttract, your end-to-end solution provider for informational webinars. I'm Lori Dearman, content producer with WebAttract, and I'll be one of your hosts for today's session. And in just a moment, I'll be introducing your moderator from Desktop Engineering, Kenneth Wong, who will get our case study started with our featured presenter from Trek Bicycle, Mike Ziegle. You'll also have an opportunity to have your questions answered at the end of the presentation during the Ask the Experts panel session. But for now, let's get started, as we do have a lot to cover. And to get started, I'd like to share with you some information on who's registered today. We're very excited that we have a diverse audience of over 250 professionals from 5 countries and 38 states and provinces, representing consumer electronics, defense, government, education, medical, and other industries, all to learn about rapid prototyping and how it can accelerate your design cycles and help you bring better products to market faster. Now, regardless of your industry segment or location, we're confident that you'll find today's webinar of value. Now, as I mentioned, the host of today's webinar is Objet, and before we get started, I'd like to turn it over to the Director of Marketing at Objet, Bruce Bradshaw, who'll take just a moment of your time to officially welcome you and express what he hopes you'll get out of today. Bruce?
Lori, thanks very much. As Lori mentioned, real briefly, I'd just like to welcome everyone to our webinar. You'll hear from Mike Ziegle at Trek, who has been using our machine for a number of years, and you'll hear what he has done with it and how he's helped his organization with rapid prototyping. But my official goal right now is to welcome you, as well as Mike, for doing the webinar, and as well as thanking Desktop Engineering and Kenneth Wong for hosting this for us. So I'm going to cut my welcome short now and pass it over to you, Ken, to kick off the webinar.
Bruce, thank you very much. Well, hello, everybody. Welcome. I'm Kenneth Wong from Desktop Engineering Magazine. Well, let's get started. Now, prototyping, simply put, this is about making a mock-up of your product. Is an essential part of product development, of course. Some manufacturing firms and design shops like to build the prototype in-house. Others like to outsource them to service bureaus, which will then create and deliver the mock-up for a fee. Now, if you outsource your prototypes to a service bureau that might use a rapid prototyping machine or a 3D printer, they'll quickly turn it around and send it back to you when the order is complete. So if you tend to change your design numerous times in the prototyping phase, for instance, or if you're the type of manufacturer that like to evaluate several design variations for strength, durability, and aesthetics at the same time, the cost of ordering these prototypes could very quickly add up. So my guess is sooner or later, you're going to have to confront this question. Can I afford to keep ordering prototypes? Or is it more economical to invest in a rapid prototyping system? Well, in a moment, we're going to meet someone who can help you answer this from his personal experience. But before we start, before we meet our presenter, I just want to find out from you, first of all, how familiar you are with rapid prototyping and how pervasive this is as part of your normal daily routines. I'm going to ask Lori. Lori, if you will, can you help me do a couple of polls?
I sure can, Kenneth. And coming up on your screen right now, you should see a question. Are you currently using rapid prototyping as part of your design process? And if so, in what form? So the first option, yes, we outsource it. Yes, we use both in-house systems and service bureaus. No, we're not. Or yes, we do it in-house. And seeing those votes coming in right now, I'll give you just another few seconds to weigh in on that before we close it and share it out with the audience. All right, there it is. Kenneth, any comments on that?
Yeah, well, first off, I can see that there is actually a fair amount of people who outsource their products to service bureaus, and then there's also a good amount of people who have not discovered rapid prototyping for some reason. I would say that if you outsource it to service bureaus, this is the kind of thing that you want to keep an eye out on, because depending on how iterative your process is, how many iterations you do your design, this could very quickly add up, and that turns out to be the case with our presenter's company. Let's do another poll to find out a little more about our audience familiarity. Laura?
Yes, let's do that. So coming up on your screen right now, if you outsource your prototypes, roughly how many models do you outsource per month? And those choices: less than 1 per month, between 1 and 2, between 3 and 5, or is it more than 5? Let's take a look at those results, shall we? Kenneth, any thoughts on those?
A lot of people are saying, at least on this webinar, that they are sending out less than 1 prototype per month to service bureaus, of course, and that could mean that they feel that this is quite sufficient. And a lot of the time, people also have been experimenting with digital prototyping as opposed to physical prototype testing out. And I would say that there are, depending on the kind of product that you manufacture, in some cases it is actually a must and absolutely necessary to test it out with a physical prototype. So this is probably the reason that people feel, even though they have the digital 3D models, they still need to print out or manufacture a rapid prototype of their product once every month. Okay, well, thank you very much, Laurie, for helping us do these polls. Now I think it is time to meet our presenter. And I am delighted to have with us Mike Ziegle from Trek Bicycle. Mike is the manager of prototype development group at Trek, and he brings with him over 20 years of experience in the field of engineering. Mike, thank you very much for joining us.
Thank you, Kenneth. It's a pleasure.
So, Mike, before we get started, would you mind saying a few words about Trek, the company you work at, and your role specifically in the company?
Sure. Trek started in 1976 in a small barn in a small town in southern Wisconsin. It's privately owned by the family of Dick Burke, who was one of the original 2 founders. It was initially known for its hand-built silver-brazed lug steel frames. Trek's current flagship bikes utilize our proprietary OCLV carbon fiber technology. I started at Trek in 1989 in manufacturing engineering. I later moved to design engineering in 1992, and in 1996 was asked to join the Advanced Concept Group. And one of my duties in the Advanced Concept Group was to develop in-house prototyping resource. From a 1-person resource in 1996 to our current team of 8 very talented people, you can see our prototyping focus at Trek has increased considerably. Currently, our prototype group, besides the Objet Connex 500, is composed of 5 CNC machining centers, 2 CNC lathes, 1 CNC router, and a complete welding and fabrication shop. Trek employs 1,785 people worldwide at 24 office locations in 17 different countries. Currently, over 50% of the company's profits come from sales outside the U.S. Now, all this is from a company that started in a small barn in south central Wisconsin. By the way, you can see a picture of the barn on your screen there on the left. By the way, that barn's still there, and we use it currently as our mold shop for machining our carbon fiber molds for our carbon fiber frames.
Thanks, Mike. By the way, I can't help but notice some similarities between this gentleman on the bike that we saw just earlier and that screenshot driven by Glory and you. Is that you in that picture, or is that a founder, or is that some kind of biking celebrity, Mike?
I think that's a picture of Lupe.
Okay, well, Lupe is your colleagues that we're going to be meeting soon, and he'll be fielding questions for us. All right, Mike, now, could you help explain how Trek uses rapid prototyping in its design development practices?
Yes, Kenneth. Multiple groups throughout Trek use rapid prototyping in their product development cycle. And this can range from initial concept all the way through manufacturing, engineering, and continuous improvement teams. The prototype group is a part of Trek engineering. However, we support all groups within Trek regarding prototype needs. And this also would include our European arm of the country. As a note, I just talked to Lupe this morning, and we talked about how long it took to get a part from here to Europe, and it's basically 3 days from our dock to there. So in some cases, it's quicker for them to get a part from us than it is to locally source it. Another thing we're seeing more of is design for manufacturing. Having prototypes early in the development cycle can be valuable in looking at potential production issues created by a new design. We don't have to wait for a forging or a casting production part to actually work on tooling. We can use prototype parts to do that. Requests from manufacturing engineering for short-run tooling, paint mask, prototype tooling, and prototype parts that I just mentioned used to validate production tooling. This is one of the things we didn't initially anticipate when we bought the machine. We didn't foresee it being something that manufacturing engineering would use as much as it does. Kind of along the same line, it's kind of crazy. We no longer make most of the type of parts that we bought the machine for. Those parts we more often do now on our CNC router, and in some cases we still outsource some of those parts. Once we got the machine, the engineers, designers saw what it could do. Demand for other applications more suitable for the Connex has filled our queue and then some. We just found that maximizing the number of design iterations, the more we can run, the more we refine the final product. We found that having easy access to prototyping in-house has promoted designers to do more prototypes. So it's kind of a self-generating process here. The more parts we make, the more we want. The end result basically is getting a better product to market quicker.
Okay, well, thank you, Mike. So you're going around doing your different iterations of design over and over. Can I ask you when you start to see red flags? What makes you, for instance, decided that you need to take a long, hard look at the cost of service bureau prototypes?
Sure, Ken. That's a good story. The prototype development group was focused on making CNC and fabricated parts for our frames and our engineers and designers. Rapid prototyping really wasn't on my horizon. The engineers and designers, before we brought in the Connex, were sending rapid prototype parts out on their own, not always done in an efficient and a coordinated manner. I was not the original champion of bringing rapid prototyping in-house, so I can't take credit for being the visionary who anticipated that need. One of our engineers, Scott Stryzik, had rapid prototyping experience at a company he worked at before coming to Trek. Scott saw a need and did a return on investment study to justify the purchase of rapid prototyping machine. Although the findings of this ROI study were positive, for whatever reason it was not acted on. 1 year later, my boss, the director of engineering, asked me to revisit the option. Preceding year, we spent over $275,000 on rapid prototype parts. And this, Ken, was the red flag that you talk about. It started the ball rolling.
Yeah, at $275,000, you're already reaching the kind of price point where you could conceivably buy a rapid prototyping machine, so to speak. Now, you probably look at several different options when you decided to bring rapid prototyping in-house, shall we say. Can I ask you what you remember about the evaluation process? How did you decide which one to root out, which one to keep on the short list?
Kenneth, I have a very large 3-ring notebook documenting the search. We really spent a lot of time on it. This was a large expenditure. It was double what we had spent on the largest piece of equipment in the shop, which was a CNC mill. So we did a really exhaustive study on the processes available and also the companies that were selling the equipment. During the evaluation, we looked at the physical and mechanical characteristics of each system's available materials, and also surface quality, part accuracy, build envelope, ease of changing over materials, and what kind of post-production cleaning finishing is required. Skill required to program, set up, and operate the machines were also something we looked at closely. And in final, equipment and material costs were big, as you can expect.
Of course, yeah, material costs could add up too if you're constantly churning these out. Okay, so if you still have this 3-ring thick binder that you kept your note, I'm going to ask you to refer to it again if you can and tell us what exactly it is about Objet's Connex 500. What are the characteristics or what are the features that you feel tip the scale in its favor?
Well, after careful evaluation, and this is kind of a step sideways in the discussion, we decided that SLA process was the technology that best satisfy our needs. One of our industrial designers, Ned, told me about a new RP process he saw while on a business trip. Sounded interesting, so we decided to take a look at it. We had a sales rep from Objet came to Trek to do a sales pitch. Presentation spiked their interest. It was almost, I hate to say, it's kind of a cliche, too good to be true. I asked them to come back and do the pitch for the director of engineering and a larger group of engineers and designers. I guess the thing that in the presentation that really tipped the scale was the ability of the Connex to print digital materials. This is the kind of the thing that caught everybody's attention. Multiple durometers, colors, material types, all in a single build. It was a huge leap over the other technologies we had been looking at. Before the presentation was even over, my boss said, "Buy it," and walked out.
That sounds actually like a direct order, and you probably took it as such.
You're correct, yeah.
Well, you mentioned digital materials and durometer, so I think it's important to note that a lot of the times the type of material that's available for somebody to print with in a machine can really determine how well the mock-up of the prototype mimic the manufactured product in its tensile strength, in flexibility, brittleness, and texture. So can I ask you what your experience was with the parts that were printed in Connex 500?
You're correct, Kenneth. Range of materials is really a key factor. The ability to vary the physical mechanical characteristics of the prototype gave our engineers and designers more range to experiment with during product development cycle. It also allowed them to create prototypes with characteristics close to those desired in the finished product. At Trek, we create a lot of parts that involve ergonomic design, basically designs where the rider interfaces with the machine, either through the seats, handlebars, controls, pedals, shoes, etc. The ability to create these parts in the desired durometer was a real plus for our designers. Designers use this ability not only to specify the correct durometer, but also to experiment with multiple durometers in multiple iterations. Along the same line, Trek has 14 miles of dedicated off-road trails that have been created and maintained for testing and recreational use by Trek employees. We also happen to be situated in a rural area surrounded by miles of lightly traveled blacktop farm roads. These provide an excellent test bed for our products. An engineer can take a prototype part, assemble it on a bike, and within a few minutes be out on the trail or on the road. And in some cases, particularly with Objet parts, you can do another test later in the day with a different iteration.
Okay, so I saw earlier that Trek's headquarters is in Wisconsin. Is that correct?
That's correct, Kenneth.
So I can't imagine you running on that track, biking on that track all year round. What happened when the track becomes snow-covered in winter?
We have some serious enthusiasts here at Trek, as you can imagine. We have some riders that commute all year round. It's not unusual to see a bike by a desk in the winter with studded tires on it. We also have a small group that goes out almost daily in the winter to ride off-road, either on our trail system if it's adaptable, or on local snowmobile trails. Trek also has a partnership with Raise, an indoor bike park for those who like to ride in a more comfortable environment.
Wow, well, better you riding on these freezing temperatures than me, I'd say. Now, if you can help me also understand, Mike, how would you justify your own purchase of the machine? So let's say if you take the Trek's prototyping workflow and show us how long it takes, if you do some rough numbers and calculations, how many units does it take, or how long does it take before you feel you have seen a return on your investment?
Kenneth, as I mentioned earlier, our original justification study focused on building a type of part that our Connex really doesn't build anymore. That study may not be relevant, but given the number of parts that we expected to do versus what we're doing now, I believe the return on investment is much higher than we anticipated. A couple things that come to mind when I think of rapid prototyping, or prototyping in general. Someone smarter than me once said the biggest cost you could possibly incur is that of bringing a poorly conceived or badly executed product to market. The other one is, the other cost we're concerned about is a potential loss of sales due to bringing a product to market late. We still do some RP parts outside, but I would say 90% plus we do inside on the Connex. Example of the number of parts we've done. In 2007, the year before we bought the Connex, we completed 272 project requests in the prototype group. In 2010, 3 years later, we completed 1,119 requests. It's a fourfold increase, and most of those are due to the Connex. We expected to use the machine 2 or 3 hours a day, and we're going to staff it as an additional duty split between the rest of the guys in the group. Within 6 months, we had to bring on Lupe as a full-time operator, and the machine runs approximately 60 hours a week. Once the designers started to realize what we could do on the machine, its use exploded. As a unexpected benefit, designers will now often do their first iteration on the Connex, where formerly they would have done it on the CNC machine. By doing their initial iteration of the Connex, we free up the CNC machine for items that really need to be done in hard materials, and also the engineers get their parts quicker. So it's kind of been a twofold benefit that we didn't really expect. Basically, the ROI, the part that's hard to define, is a dollar benefit to Trek in getting great product to market quicker. And I think this may be more valuable in the long run than the actual part cost savings.
So, Mike, now that you have the ability to produce a lot more prototypes, how does that improve your new products? Is there, for instance, a Trek bicycle model that I might find in a normal bike retail shop where if I look at it, I can say, well, this is the part that is probably done a lot better than it should have been or could have been because Trek has ability to prototype in-house. What were the things that you discover or improve on with your designs?
Kenneth, we use the Connex across the board on all Trek and Bontrager brand products. Our designers and engineers are continuously finding new applications with technology. Examples of some of the things we make on the Connex would be tire tread cross sections, helmets, helmet parts, buckles, bicycle seats, computers, lights, grips, handlebars. We probably make a new variation of an Aero handlebar about every 2 weeks. One of the most interesting teams we work with is the group that does wind tunnel testing. We do extensive wind tunnel testing on our bikes and bike components. Our engineers will start with a cross-section or component design with the help of our computational fluid dynamics software, and they'll do that here in Waterloo at their desk. From that, they'll send us the model, we'll create prototypes, then the engineers will travel to the wind tunnel in San Diego to validate the designs. Because of the cost of wind tunnel time, multiple iterations of the part are created to test small design variations for effectiveness. We average around 100 hours a year on wind tunnel time, and I think over the period that we've actually done wind tunnel testing, we've got about 1,000 hours of wind tunnel real time. We've even done work on off-road and racing bikes and their riders. Tracy Mosley, our Trek sponsor, 2010 Women's Downhill World Champion, spent wind tunnel time last year optimizing her riding position and also testing some prototype aero enhancements on her Trek downhill bike.
So, Mike, one of the concerns that people might have is, of course, the impact of moving a large piece of equipment or hardware, and along with printing materials into a working environment. Can you talk about where Trek set up the Connex 500? And, for instance, what's its power consumption? Does it increase all your electric bill? Or what's the noise level like? Does it interfere with your normal design activities? How about materials in the air? And what are the kind of experience that you have had with having a physical machine close by?
Kenneth, initially we thought about putting the Connex machine in the engineering office, but it was thought that it would be a distraction to the engineers constantly going over and taking a peek at and seeing where their projects were. So we ended up putting it in our shop. The shop has TIG welders, milling machines, lathes, sanders. There's actually a heat treat oven nearby. Machine seems to be pretty environmentally friendly. As far as power goes, we've got a backup power source for it, but other than that, the power requirements were not unique. The area that it is in is air conditioned, but otherwise it's a standard shop environment. We've really experienced no issues with the machine environment since we purchased it. On the other side, it's quiet when building parts. I'd say it's about as noisy as a refrigerator. The machine that removes the support material is a little noisier, maybe more like a dishwasher running. So I guess the environment, you might say it's like working in a kitchen.
Well, I know I can't cook up new bike designs in my kitchen, so all the more power to you, Mike.
Thanks, Kenneth.
Well, I really appreciate you sharing all these information and insight with us. Now, I think I'm going to call back very soon. We're going to call to our virtual podium your colleague that we've mentioned numerous times, so people are, I'm sure, curious and wanting to meet him, Guadalupe Ollarzabal, the man who's going to help us field some of the technical questions because he's on the front line involved in printing these parts. But before we do that, I think it may be a good time for us to bring back Bruce from Objet because he can tell us what his company has been doing to improve the 3D printing process and the experience, the user experience, and the kind of materials that are available that you can experiment with. So Bruce, welcome back.
Ken, thanks very much. I appreciate it. And Mike, once again, thanks for that information. I'm sure it's very interesting for the folks listening today. For us, for folks that may not be familiar with Objet, we really, what separates us from some of the folks that you may know in the industry is really our ability to match the end product for folks. Having 14 base materials that run through our majority of our printers, as well as 51 digital materials. Mike had referenced those in his presentation, giving us a total of 65 total materials from our RP machines, gives our end users a lot of flexibility and allows them to pick parts that are much closer to their end product when they do testing for fit, form, and function. Other small things that that may separate us really is our fine details and smooth surfaces, and that's really achieved by the thin layers that our printers print. They print in 16 microns, allowing you to do very thin walls and highly accurate parts. And as Mike mentioned before, our printers are very office friendly. We have 5 of them in our office right here, just outside my office, and they work great in an office environment, unlike some of the competition that may have a back room or back office type of environment. Also, again, if you're not familiar with Objet, it can be found in a number of different industries. You can see from the different companies that are leveraging our technologies, from automotive companies to consumer goods, electronics, medical devices, biomedical industries, education research institutions use it, as well as a number of other places like architecture and places like that. Briefly, I'm just going to talk, Ken, for a minute about the technology that Objet utilizes. It's an inkjet technology, much like your inkjet printer at home, in a very rudimentary way. It functions just like that printer. Rather than jetting ink, it's jetting a liquid resin that gets cured with a UV light, and it builds up the part layer by layer. And as I mentioned before, it's in 16 micron layers. What is good for us is we can leverage the billion-dollar investment that the inkjet technology is already used for wide format printers and things along those lines. So as finer detail ink heads or faster technology comes into play, we can leverage that technology. It's not just Objet engineers working on our technology. It's a whole billion-dollar industry. And that helps us, advance our technologies with products like the Conics that Trek is using today. As it relates to the Conics, again, Mike had mentioned digital materials, so I'll expand on that just briefly. Digital materials is the combination of taking 2 materials. It could be a flexible material that we refer to as a Vero material and a rigid material, and our product name for that is called a Tango material, a flexible material. And I can combine those 2 materials in the same part and not only get half of my part flexible and half of my part rigid, but I can also get, by blending those same 2 materials, as many as 11 different material properties printed all at the same time. That's a homogeneous part that allows me to do lots of different testing for grips, as Mike pointed out, tires, things along those lines. So in Mike's case, if he is printing a grip for his handlebars, he can print out 11 different variations of those that all have different parameters just by combining 2 separate materials. So the Conics truly brings a unique capability to the market, unlike other technologies in the prototyping world. Ken, you also mentioned, and Mike referenced, the amount of dollars they spend for prototyping. And what's good from Objet's point of view is we have a range of product families, and I won't go into great details, but here's a very high-level overview of them. We have a desktop family that for basically just under $20,000, $19,900, you can get into the desktop, 3D printing world. We have our kind of mid-range family, which we call the Eden family, that gives you flexibility in terms of speed as well as print size. So you can get as large as a 16 by 20 by 8 part from our Eden 500V. And then, of course, there's the Conics, which Mike's talked about and we referred to in previous slides. And related to the Conics, it really provides a lot of different flexibilities for folks in terms of application testing. There have been some questions that I've seen pop up where people are asking what they do, how Mike and his team uses the technology. These particular applications like overmolding or soft touch handling, doing labeling and text, living hinges, you see that all the time. We see it all the time with our customers. Prior to the Conics, they would tape two pieces together to simulate a living hinge. Well, now, because of digital materials, I can print 5 different versions of a living hinge to determine which one is best for it, along with a snap fit. Things like dynamic friction, printing gaskets and seals, shock absorption, and obviously impact resistance to ensure design can withstand a desired force or impact. Lastly, this is one thing that I'd like to touch on, and again, I've seen some questions pop up where people are asking about materials. I just want to mention for the audience that we've recently introduced two new materials. One is called Vero Clear. So for applications like in the automotive industry that you're doing lenses or cosmetics, consumer goods, it's a great application, great material for applications like that allow you to do much more than you could do with previous materials. We've also introduced an ABS-like material that allows you to do to do much greater functional testing. It simulates engineering plastics and being able to kind of push the limits from a temperature standpoint as well as a hardness standpoint with ABS material. The goal here, like I mentioned at the beginning, is to allow our customers to better simulate the final end product in the development stage. And the combination of our systems as well as the materials we provide, I think, allow people to do that. So with that, Lori, I'm going to pass it back to you, and we can begin the Ask the Experts segment of the webinar, if you don't mind.
Okay, and before we do that, you want to just mention how folks can get more information?
Sure, absolutely. Obviously, you can visit our website at objet.com, or if you have questions specific and directed at me, feel free to email me at bruce.bradshaw@objet.com.
All right. Thank you, Bruce.
Okay.
And with that, I would like to ask Mike Ziegle to step back to the virtual podium and also take a moment to formally introduce Lupe Ollarzabal, who operates the very busy Connex 3D printer at Trek and has logged literally thousands of hours cranking out parts for Trek engineers. And he'll be joining Mike and Bruce on our expert panel today. So with that, why don't we get started with the first question that I see coming in. And that is, does Trek perform finishing machine operations on their 3D printed prototypes for smooth appearances? And if so, what coatings or paints are typically applied to the surfaces? Mike or Lupe, we want to...
Yes, hello, Lori.
Yes.
Yes. Yes, this is Lupe. I've been at Trek here for 16 plus years now, and right now, as of now, I'm running a Objet Connex 500, and for that question, we will sometimes post finishing of parts that we send to the wind tunnel. We also polish clear parts that need to be optically presentable. We seldom paint parts, but when we do, there's a two-part component polyurethane, and when we do tires, the trails for that we just use a rattle can flat black.
I see. Well, thank you very much. And one more question coming in. And this one, the attendee would like to understand more of how Trek goes from an idea to final design and how often rapid prototyping is incorporated, and roughly how long does this take?
Lori, good question. I'd probably fill another three-ring notebook. Trek has a very detailed process they follow throughout the product development cycle. Duration of the cycle really varies a lot depending on the platform and complexity of the design, as you can imagine. Often, but not always, the idea will start in the advanced concept group for conceptual work, then once desired final product parameters are determined, it'll move to product development, and then finally to production. How often is RP incorporated? It really depends on the project. Some projects use no rapid prototyping. Others may do multiple iterations on multiple parts. We bill our customers internally for resin used, and this seems to help to ensure that we are not doing unneeded parts. How long the process takes? Excluding R&D time, it can be anywhere from 240 days to 18 months for a product development cycle.
Well, excellent. Thank you. Another question coming in. Are these prototypes show and tell, or can they be used for testing part strength, deflection, etc.?
I can answer that, Lori. Both, mostly show and tell, but I guess show and tell, a lot of times we'll make a part, for example, a dropout for a bicycle, and it'll be to look at it, not only aesthetically how it looks, but we can also use it for fit and function. We can fit it up to mating parts. As far as testing mechanically, we don't do that too often. I'm trying to think of an example where we might do it. But we actually make structures. Some of the guys, engineers, have to be careful because they'll try to go and take something that we may not feel like should be used for function and actually try to ride with the parts. So as Bruce mentioned earlier, some of the materials now, like the ABS-like materials, are starting to have some mechanical characteristics that make them more usable for that type of part.
Lori, if I can add to it, this is Bruce.
Yes.
Mike is one example, but we have many customers that do other things like in the electronics field will actually print a prototype and drop electronics in and do real-world testing, if you will, to test the ergonomics for the product, or they may do a small test run in a small focus group type thing. And again, because we have the ability to print flexible materials, one example that we've seen is folks have print 5 different versions of a cell phone, and the different flexibility, if you will, of the keyboard itself, being able to test, all right, is this rigid enough? Is it soft enough? Is it too soft? That kind of stuff. So the types of testing is a wide range, and Mike just touched on it with the additions of the additional materials. To do engineering plastics will allow folks to do much more real-life testing of what the final part will be in combination with the materials that we have today.
Okay. Well, thank you, gentlemen. Our next question, aside from the upfront cost of the rapid prototype machine, what percentage would you find the cost of material versus the outsourced costs of a particular part? So I think we're trying to get to the percentage of the cost of material versus the outsourced cost of a part. Anyone want to?
Mike, I don't know if you want to. This is Bruce. I can field some of it. We know that depending on a service bureau that you use, it can be anywhere from 4 times to 10 times the cost of the actual material. But in general, just to put it in perspective for folks, the average cost of a part for an object part is somewhere between $5 and $6 per cubic inch. It clearly depends on part geometry, things along those lines, but that's a relative cost, and that's very similar to what most of the prototyping technologies will deliver. We are right in the same price range, if you will, compared to the competitors. But versus a service bureau, depending on, again, the part, the size of the part, it's anywhere from 4 to 10 times. The other thing that folks don't tend to focus on, and Mike mentioned it in his presentation, is not only the cost of the material, but when you outsource, it's actually the time to get it. There's a lot of companies that that use our products that their design iterations are very fast, and they need a part today or tomorrow to evaluate whether the design goes to the next phase gate. So it's not only the time that you send to the service bureau, it could be 2 or 3 days before you get a part back, but it's also the internal process of cutting a PO, getting that PO approved, all that fun stuff that actually adds to the length of time before a designer has a part back in their hand. So what typically is quoted as a 2 or 3 day turnaround from a service bureau ends up being a week for the actual designer to evaluate their design. So not only cost of the part itself, but the cost of actually bringing products to market. And Mike, I think you mentioned it before, the cost savings that Trek has realized is due to a lot to time to market, not so much the actual savings in the material.
All right. Next question coming in. How much is a Connex?
We have 2 different Connex products in our repertoire. One is the Connex 500. That's the one that Mike has. We also have a Connex 350, which is a little bit smaller. Between the accessories and service and things along those lines, the Connex 500 is somewhere in the $260,000 range, and the Connex 350 is in the $220,000 range. Those are U.S. pricing that I'm giving you. Again, they range depending on the type of options folks want, but that puts it in perspective. And again, Kenneth had referenced, $275,000 in part cost for Trek. This is obviously doesn't even take into consideration the time to market that these guys get.
Okay. Here's one. What post-processing, in parentheses polishing, is required with VeroClear to evaluate optical parts?
Mike, I don't know if you've actually used VeroClear yet. Again, that's a recent addition to our products. I can help answer that, but I don't know if you've had hands-on experience with it yet. Lupe?
We just got delivery of something today. Lupe, have you yet to use it yet?
I haven't used it yet. We're working on a project soon, so.
Okay, so I'll take a stab at it, but I encourage folks to go on to our website. There are application notes on those materials to you on how to best get the best results from them. But in general, depends on the thickness of the part. But in general, with VeroClear, one of the advances for us is really it just comes down to polishing and a little lacquer. There's some samples on our website that you can see where there's an actual optical lens. And again, it really depends on how sophisticated you're trying to get and how close you're trying to match the end product. But to get real clear images, polishing and lacquer is really the all that's really needed in order to get a clear part.
All right. Well, there are fabulous questions coming in. Another one here is, how often do you have to service the machine?
Mike, I can give them our average, and I don't know if you want to talk about your own experience.
Sure, why don't you start, Bruce?
Yeah, sure. So we typically have in our service contracts, we have 2 preventative maintenance visits a year, and that's about average for what we see for our customers. Clearly, it's a machine that has working parts, and there are times when we need to have service done. But on average, it's 2 to 3 times a year, and those typically fall into the service contract. Obviously, there's outliers from those, but that's on average what we see from most of our customers. Mike, I don't know if that's what you experience where you guys are.
Yeah, we have the service contract also, Bruce, and we had one of the first machines Connex 500s made, and we did have some issues with it earlier on, and I think that was some teething problems. They were all covered under warranty, and since that time, we've had very few out of the 3 years. Very few times recently where we needed any kind of service other than the scheduled services.
That's great.
Yes. And what software?
Lori, I'm sorry.
Go ahead.
I'm sorry. Let me just add one other portion of that. Every year we do a survey out to the customer base for Objet worldwide, and we, for the last 3 years, have gotten very, very high scores. We rank them from 1 to 5, somewhere on the range of a 4.4 to a 4.6 satisfaction rating back from our customer base on reliability and that kind of stuff from our user base. So that's, again, from the users telling us what they feel as just an added point.
And that's a great track record. Okay, what software is required for model?
Again, Mike, I don't know if you want to talk. Yeah,
I can tell you what we use, and Bruce can maybe fill in that. Most of our modeling here at Trek is done on SolidWorks, we have some alias stations, but SolidWorks is our preferred modeling, and we convert it right from a SolidWorks file to an STL, and that gets transferred to the Connex.
Yeah, that's great, Mike. Most of the 3D modeling applications do what Mike referred to. They allow you to export an STL file, and our printers accept those, as well as many of the competitors in the industry. It's kind of a file format that's kind of it has become a standard. So whether you're using an Autodesk software, PTC, Siemens, any of the CATIA, any of the large ones, most of them allow you to export an STL file to print on our printers.
Okay, and here's a question about your internal billing. How do you figure out internal billing? Priced by the material and support, or some other way?
Good question, Lori. In the prototype group in the past, we didn't bill our customers internally. Basically, we have a budget that supplies materials, resources, and the engineer would submit a project, and they would get the project at no cost to them through their individual project account anyways. When we got the object, it became so popular that we had to find a way to bill our customers. So we kind of use a hybrid billing process, and it helps, tells us a lot of things, tells us what we're doing, how much of each material we're using. End of each month, Lupe puts together a spreadsheet, sends out to all the project managers, showing them exactly what their project's been billed for the month, and so we basically just bill them for the resin cost. So the support and resin material, they get billed for that. There's no labor or overhead cost to them. So it's kind of, like I say, a hybrid billing process, and it works well for us internally.
All right. And how long does it take to print your typical part, and what size would that be?
Lupe?
Well, our prints, what I do is basically I get all small parts and run those right away in the morning, and that can be anywhere from 2 small parts to 50 small parts. And then at the end of the day, I run all the big builds, which usually take 12 hours, 18 hours. I'll helmet on Friday afternoon, and by Monday morning, the engineer will have it on his desk. So it depends on
Yeah, sorry, Lupe, it's Bruce. Yeah, I think he was going to say it really depends on the part, and that was one of the things I was going to reference. Yeah. Again, part geometry plays a lot into it, but on average, it's about 1/2 inch an hour in the Z direction most of our printers print. So the higher you go in the Z direction, the longer it takes.
Okay. Has rapid prototyping enabled Trek to retain more of their manufacturing in the U.S.?
That's a good question, Lori. I don't know if I'm prepared to answer that. Our goal at Trek is to keep as much, and hopefully our final goal would have all the production here, because we move it offshore. There's obviously some distant communication issues and things like that. I don't have an answer for that, other than I know it helps the engineers keep the design work here. So if nothing else, that's probably a plus.
Fair enough. All right. What size parts will the Connex 350 and 500 produce?
I'll take that, Mike, if that's okay. The Connex 350 is a 13 by 13 inches wide by 13 inches wide by 8 inches high, and the Connex 500 is 16 by 20 by 8 inches. I will also comment, we have a lot of customers, and Mike, your parts are less required for this, but we have folks in the automotive industry, as an example, that will print a dashboard. They'll print 3 sections of the dashboard and glue them together and sand them out and have a full-size dash printed off of our 500 products, the Eden 500B and the Connex 500.
Okay. And can you talk a little bit about how the insert molding works? What type of fixture is required?
Mike, do you do any of that? Do you actually tap or do anything like that with any of the parts that you print, or doing anything from a molding perspective?
We tab parts for ease of gluing them together. Is that what you mean? I'm not sure what the question's asking.
Yeah. I'm not sure if it's relative to molding or relative to actual the part themselves, but I'll let you, I guess, explain what you guys do for tapping, and then I'll talk a little bit about molding if you want.
Well, if it's related to tabbing, things like that, we'll have some handlebars we want to connect. Like Bruce said, they'll make a dashboard. It's 6 feet long or whatever. We'll make parts quite often that either won't fit on the table, or to keep the z-axis down, we'll break it down into smaller parts. An example would be a bicycle handlebar off a road bike. You can imagine it's kind of got that bull's horn shape to it. We'll break that down into 3 pieces so it lays flat on the table. We can make it quicker with less support material. And either Lupe or the engineer will design tabs to interface between the 2 parts. So when we do put them together and glue them together, they're self-indexing. It just makes assembly easier.
Okay, Bruce, did you want to add anything to that?
No, I think I'll let that go for now, and we'll try to answer it a little bit more in depth through email, if that's okay.
Yes, sounds good. And how about we make this our last question for today? And let's see. Mike, do you use the Connex only for rapid prototyping or for mass manufacturing also?
We make a number of parts. Sometimes, and Lupe can tell you more, sometimes we'll make a lot of parts, if they're small parts particularly. I think of something that comes to mind would be cable stops, prototype cable stops, or what we call jewelry on a bicycle, where we'll make a number of them for testing. But as far as production parts, actually production, and Lupe can answer this if he can think of something, but I don't recall production parts per se. We make tooling and fixturing for production, but not production parts. Lupe, can you think of some examples?
Yeah, Mike. The only examples I have is for the paint line, they use a new swing arm or something, and they want a plug so paint won't get into that part, to that bearing part. I'll print out a few just to get them rolling, and that's as far as we go for production. So just plugs for paint line.
Good example.
Well, Lori, I'll add to that as well. This is Bruce. The industry that Mike's in is probably not a good example of where production parts are used off of RRP machines. The dental industry and the hearing aid industry is where we see a lot of actual production parts being used. It's not actually just for design and test purposes. It's actually used in the actual final product in those fields. Also, again, with ABS-like material, that game may change a little bit, where we may actually start to see some production parts for very short-run stuff being used for folks like Trek or people that are in the consumer goods or consumer electronics industry. Jigs and fixtures in a manufacturing environment is places where you'll see one-offs. Medical device manufacturers will also start to see some of that stuff come to fruition because of the ABS-like material.
Okay, well, I thank you, gentlemen. And before we conclude, Lupe, do you have any closing comments you'd like to leave the audience with today?
Well, just weather's turning nice, and keep riding those bikes.
Fair enough. How about you, Mike?
Here, yeah.
I don't know if I could do better than Lupe's, but thanks everyone for your participation in this webinar.
Very nice. And Bruce?
No, again, thanks so much both to Mike and Lupe and Ken and yourself for hosting the webinar. We appreciate it, and I'm quite sure folks got a lot of good information out of it. Thanks very much.
Very good. And we still do have a number of questions in the queue, so we will be getting back to you offline with answers to those. But we are just about at that time, and before signing off, I'd like to thank each of you for joining us and trust you found today to be of value. And of course, special thanks to Mike and Lupe on our thought leadership panel, and to our sponsor and host, Objet and Desktop Engineering. As mentioned, you'll be receiving a short survey at the end of the webinar today, and we really would appreciate you filling it out, as we value your time and your feedback. But most importantly, thank you all for joining us. And on behalf of my co-moderator, Kenneth Wong, this is Lori Dearman saying, have a great rest of the week.